السلام عليكم ورحمة الله وبركاته. نراجع مع بعض Grade 12 Advanced. Question number 1. How will the equivalent resistance between the two points A and B changes if we remove one of the resistors from the set shown in the figure? If we remove any of these resistance, the equivalent resistance will increase. In parallel connection, if we remove the resistance, the equivalent will be increases. If we add more and more, the equivalent resistance will be decreases more and more. Question 2. Three identical resistors R1, 2, 3 are wired together as shown in figure. An electric current is flowing from point A to point B. The current flowing through R2 is equal to if there is a I total come from this side, it will be divided into three currents. They equal each other because the resistors are equal to each other. So that I1 will equal I2 will equal I3. Why? Because V1 equal V2 equal V3 in parallel, and R1 equal R2 equal R3, so that the current 1 equal the current 2 equal current 3. The next, based on the data shown in the adjacent circuit, calculate the amount of resistance R2. As you see in this figure, we have the current and the resistance in this branch. We have current and resistance, so that I can calculate voltage. V1 equal I1 R1 equal 2 times 6 will be 12 voltage. And as you see, this resistance and this resistance in parallel, so that the voltage is constant. So that the voltage for this resistance is LV2 equal 12 also, and I2 equal 1 ampere, so that I can calculate R2 equal V2 over I2 over I2, it will be 12 over 1, it will be 12 ohm. The same question, but we need to calculate EMF, and we need to calculate this current. As you see from the figure, the current I1 is 2 ampere, I2 is 1 ampere, so that the I total come to this junction will be I total will be 2 plus 1 equal 3 amp. The same circuit, we need to calculate V for this source. It will be 12 volt. Why 12 volt? Because the voltage across parallel will be constant 12 volt, and this also 12 volt, and the voltage for battery is 12 volt also. Question number 6. Depending on the electrical circuit shown in the opposite circuit and the data on it, calculate the battery voltage difference. Okay, let's start. We have this current I2 and R2, so that I can calculate V1 equal I1 R1. I1 is 1.5, R1 is 6, so that it will be 9 voltage. At the same time, R2 at the same time. In this resistance, we know V for this resistance will be the same, 9 voltage. And the I total is 2.5, as you see in the figure. I total is 2.5. It will be divided into two currents, 1.5 and 1. There is a current up equal 1. Why 1? Because 1 plus 1 or 1.5, it will be 2.5. So that I2 will equal 1 amp. I can calculate R2. R2 is V2 over I2 equal 9 voltage over 1 amp. R2 will equal 9 ohm. The total current pass through this resistance. The total current will be 2.5 ampere pass through 4.0 ohm. Then I can calculate the voltage for this resistance. The voltage for resistance number 3 equal I total multiplied by R3. I total is 2.5 multiplied by 4. The answer will be 10 voltage. Now, what about VMF? We can calculate it or not? I think we can. How can we calculate it? Between point A and B, the voltage is 9. Between point A and B, the voltage is 9 volt. Is it correct? Yes, it's correct. And the voltage between this resistance, we just calculated, is 10 volt. So that VMF will be 9 plus 10, it will be 19 voltage. The answer will be 19 volts. Now we calculate R2, we calculate the VMF, we calculate everything in this circuit. There is no mess on it. He asked about the resistance R2, I calculated from little. The next question, depending on the circuit shown in the opposite figure, calculate the equivalent resistance of this circuit. Okay, let's start with R2 and R3 in the same branch. They are in series, so that R2 3 equal 3 plus 9, it will be 12 ohm. This is the first step. After that, this 12 ohm will be connected in parallel with 4. In parallel, Req equal 4 multiplied by 12 over 4 plus 12. The answer will be 3 ohm. This is the Req. The next question, depending on the circuit shown in the opposite, calculate the voltage difference between 2 point A and B. If I need to calculate potential difference between A and B in this place, I need to know the current pass through R3. If I calculate this current, I can get V3. Let's start. First, the equivalent resistance for this circuit is, we calculated from little, Req equal 3 ohm. So that we can calculate I total equal delta V over Req equal 18 over 3 will be 6 amp. The total current is 6 ampere. This current will be divided into branches. There is a current in this branch and the current in this branch. We need I3. How can I get I3? I3 equal I total times R1 over R1 plus R2 plus R3, so that I3 will be 6 amp multiplied by 4 divide 4 plus 3 plus 9. The answer will be 1.5 ampere, so that V3, the voltage between point A and B, equal I3 times R3 equal 1.5 times 9. The answer will be 13.5 voltage. Question 10. The circuit shown in the figure has 4 resistors and the battery. We have the batteries and we have voltage. He asked about what is the magnitude of the potential drop across R2. We need voltage for R2. If I know the current pass through R2, we can calculate V2. Let's start. R2 and R3 in parallel, exactly. So that R23 equal R2 times R3 over R2 plus R3. R2, where is R2? 51 multiplied by R3, 114 over 51 plus 114. The answer will be 35 plus 24. The circuit will be like that. 35 plus 24. There is a resistance R4 in this branch and this resistance R1, and there is a battery. R4 equal 55, R1 equal 17 ohm. These three resistors in series connection now, so that R equivalent for the circuit is 17 plus 35.24 plus 55. The answer equal, the answer is 107.24 ohm. Now we can calculate I total pass through the circuit. I total equal delta V over Req will be 149 over 107.24. The answer equal 1.38939 amp. This current pass through the circuit, this I total, I can get and I can calculate the voltage V23 is the same with V2. So that V2 equal V23 equal I total times R23 equal 1.39 times 35.24. The answer will be 48.96 voltage. 48.96 voltage. It's near to this number. You can check again about my answer. Question number 11. What is the equivalent resistance of a circuit as shown in the figure? Let's start. We have R2 and R3 in parallel, so that R23 equal 3 times 6 over 3 plus 6 will be 18 over 9. It will be 2 ohm. We draw it again, 2 ohm, 2 ohm, and there is a battery, 110 voltage, so that Req will be 2 plus 2 equal 4 ohm. If we need to calculate the I total equal delta V over Req, 110 over 4, it will be 27.5 voltage. If you need to calculate any potential drop across each resistor, you can calculate it using the same rule. The same question. What is the potential drop across R3? Okay, we can calculate it here. Across R3, this current pass into resistor, this current 27.5, so that the voltage in this side V23 will be constant, will be remain the same, so that V2 equal V23 equal I total times R23 equal 27.5 times 2 ohm. The answer will be 55 voltage. The answer for question number 12 is 55, as you see from the previous page. Okay, what is the current through R1? The current through R1, we calculated I total is 27, as you see in this question. The same question 12 and 13. Question number 14 is different. What is the equivalent resistance of the resistor in the circuit shown in the figure? Look to this figure. The current comes from positive side, from positive terminal from this battery. At point A, this current will be divided into currents, so that this current is I2, this is I1, I1 pass through R1 and come again to junction B, and also R2 come to junction B, because there is a split for the current, so that this branch and this branch in parallel. Okay, let's start with the right branch. 4 plus 6 will be 10 ohm, and the left side 2 ohm, 2 and 10 in parallel, so that Req equal 2 times 10 over 2 plus 10. 2 times 10 will be 20 over 12. The answer will be 1.7 ohm. Thank you for watching. Have a nice day. Bye bye.